Alright, this is exercise 5G on algebraic modeling on page 299 of your textbook. As I said earlier, this is an optional exercise, or rather an extension exercise if you're up to it. If you're not up to exercise 5G, of course, just work on exercise 5A to 5F. Now this is a question, a do now question on expanding brackets based on exercise 5F. We're going to be using the distributive law, as I like to call it the Oprah law, because I have to explain it again, but it's like, you get a car, you get a car. So then it's kind of like that in the sense that if the person up here is Oprah, that's my best drawing of Oprah, by the way, you get a car in the first row, and then you also get a car in the second row, right? So whenever you expand brackets, you have to address everything inside the bracket. So let's go ahead and do this one. I have to multiply, because whatever is in the front of the bracket means I'm multiplying. So I'm multiplying for A 5 times x. Okay? But I don't just leave it as 5 times x plus 3, because I have to use the distribution law, or the distributive law, which means I multiply whatever's in front of the bracket by everything inside the bracket. So it's not just 5 times x, it's also 5 times positive 3. Simplifying that, I end up with 5x, because 5 times x is just 5x, plus 3 times 5, which is 15. One more example, same thing but with a negative in the middle. We're going to be saying, okay, well it's 8 bracket a minus 4. So if I do that, I know that I need to multiply 8 times a. So I'm going to write 8 times by a. But of course, I can't just write 8 times by a and then minus 4, can I? Because I need to use the distributive law, which means I multiply whatever's in the front of the bracket by everything inside the bracket. So we multiply by 8 here as well. Now that will simplify to 8 times a, which is 8a, minus, because it's negative 4, times by 8. So 4 times 8 I know is 32, but there's a negative in front, so negative 32. So that's it for the distributive law, expanding brackets. I'm going to be jumping into our new topic of algebraic modeling. So with algebraic modeling, like I said earlier, it's pretty much just worded problems using algebra, right? The ultimate goal of using algebra is, can I solve real life situations, right? We use algebra in a lot of everyday life, whether you know about it or not. But a lot of people in very specialized fields use algebra to solve real world problems. And so we can use algebra to model different situations. What I mean by modeling is kind of like replicating on our terms. Okay? So we can clearly define the pronumeral, remember pronumeral means the letter, and then substitute whatever we know. So for example, I can use algebra in order to figure out how much something would cost over however many hours, and then substitute how many hours I'm looking at. So for example, if you're renting a car, or whatever it is. So the example I've given here is looking at the perimeter of a rectangle, right? Just in case you forgot, perimeter is just on the outside distance. So like the fence, the length of a fence around a farm. Hint, hint, nudge, nudge might be relevant to your next learning task. The perimeter of a rectangle is given by the expression 2w plus 2l. That's just the formula that we know, where w is the width and l is the length. Find the perimeter of the rectangle if w equals to 5 and l equals 7. So they've given us the formula, or the algebraic model, and we just substitute the values in, something you guys are already familiar with. So I'm going to go ahead and copy this formula over here, 2w plus 2l, and then I'm going to substitute the values in. So I know that w is 5 and l is 7. Now I can't just write 2, 5 plus 2, 7. Of course not, because we know that if there's no operation in the middle, it's a multiply. So 2 times 5 and 2 times 7. Now that we know, 2 times 5 is 10, plus 2 times 7 is 14, which gives us 24. Now for B, it says that we need to find the perimeter of a rectangle with width 3 centimeters and length 8 centimeters. So it's the same thing. All we've done is given the extra step of saying instead of L equals 7 or L equals whatever, we need to assign the letters or the pronumerals between their numbers. So I know that for B, it says width is 3 centimeters. So of course, W equals to 3. And I know that length is 8 centimeters. So L equals to 8. And then we do the exact same thing. So I use the formula 2W plus 2L, but I get rid of L and I replace with 8. Of course, it's multiply by 8. And I get rid of W and I replace it with 3. And of course, I mean multiply by 3. I know that simplifying that, I get 2 times 3, which is 6, plus 2 times 8, which is 16. And so the answer is 22. Okay, awesome. Now that's what happens when we apply algebra to a model that we already know of. What happens if we have to create our own expressions? Now this looks a lot more difficult than it actually is. But all we need to do is create an expression, just like we've done in the past, based on a situation that's presented to us. And this is a very, very commonly mistaken concept, right? A lot of students aren't very familiar with this concept moving into year 8 and 9, so it's a good idea that you guys get it down pat now. So, for example, in A, it says that the total cost in dollars of 10 bottles if each bottle costs X dollars. So, all I need to do is figure out an expression that tells me how much the thing costs in total if I have 10 bottles and each bottle costs X dollars. Well, I treat it just like if I was at the canteen, right? If potato cakes are $2, are they $2? Potato cakes are $2, and I buy 10 of them, I'd go 10 times 2. So in our situation, I know there are 10 bottles, but I don't know how much they cost, they're X, so I just write 10X. And then I'm going to add a dollar sign on the front, just so I'm more accurate. Okay. For B, this is where it gets to be a little bit more practical. Now the total cost in dollars of hiring a plumber for N hours. Now I don't know if you guys know this, but a lot of the time, tradies will come to your house for a certain fee. So for example, they call it a call-out fee. They might charge $50 or whatever it is to come to your house and take a look. And then for every hour they work, maybe it's a big job, maybe it's a small job, whatever it is, for every hour they work, they add a certain amount. So that's like an hourly wage, just like you would at any other job. Well, not any other job, but most of the jobs. So plumbers have a call-out fee. In this situation, this plumber charges $30 call-out fee. So that's $30 flat rate, they just get $30. And then for every hour it's an extra $60. So we need to write an expression for that. So the total cost, we can say, well, we know that the $30 call out doesn't change, right? It could be 0 hours, it could be 100 hours, whatever it is, the $30 doesn't change. So I write equals $30. But we still have the $60 per hour. So I write plus 60 times by the hour, right? Because it's per hour. For every hour, it's $60. But we have to make sure that our answer uses the same pronumerals as our question. The question says that it needs to be for N hours. So instead of writing just hour, I need to write 60 times by N. Or if I simplify that, 60N. So that's exactly how we find the cost for $60 per hour plus the $30 call-out fee. I'm going to leave question C for you to go yourself, but it's the same or very similar to question B, so I'm going to leave that there. Do I have any questions? Sweet.